Okay, so we're talking about graphs of functions, and really I'm talking about functions. That's the main concept today. But before I get into functions and the graphs of those functions, I need to understand these four terms. So this is a review of yesterday's lesson. Henry, what is a relation?
I can't remember.
That's okay. It's a set of ordered pairs. It's a set of ordered pairs. It's not just a set of pairs, it's a set of ordered pairs because each pair is in a certain order. But what is the domain? Hagen, what's your domain? It's the set of oh, look at that. Good. Yeah, I put x coordinates on your notes, x values, same idea. So it's a set of x values. And you always go from least to greatest, just to make it nice and formatted. Yes, ma'am? Swivel's doing this again. You're embarrassing me, Swivel, in front of my own class. Okay, thank you. He did that last time, and I didn't catch it for a few minutes. So he was kind of just staring over there. I don't know why. Anyway, can you tell me if he does it again? Let's be the tracker of Swivel. What's the range? Eva, what's the range? The set of y values. So whenever you hear domain, you think x values. Whenever you think of range, you think of y values. Okay, so please keep those, keep tabs on that and remember that because you're going to see that. This is a whole chapter, by the way. I'm going to keep talking about this stuff. Sam, you look like you know what a function is.
Is it a special type of
It is a special type of relation. Mm-hmm. It does pass the vertical line test. But if you had your notes, it's a special type of relation. And then what was that big note that took us a long time to really nail down?
Can you read it?
You can. Yep.
Each element of the domain is paired with exactly one element of ordering.
Good. And I made you underline exactly one because that's exactly how I want you to put it. So here's a summary of that. A function is a special type relation where every x value, so I'm using the term that I use here, every x value is paired with exactly exactly one y value. So every x value is paired with exactly one y value. It has one partner. Every x value has one partner. So you got to remember that. Is it saying that every y value is paired with exactly one x value? No, it's saying every x value. And you're like, is there a difference there? Yes, there's a difference. Okay, let's look at our first part of our lesson today. So please, I'm going to keep asking you what's a relation, what's a function, domain, what's range. You got to know what it is. And if you didn't know today, that's okay. I'll test you tomorrow as well. Go ahead and draw this little chart right here. And we're going to be looking at charts a lot, which is eventually going to lead us into our graphs, but that takes a little bit of time. So I have a little chart, and it's split up into two columns, and I have 4 rows. And above the first column, I put input, and above the second column, I put output. Don't make it too small, but don't cover up the whole page with it. It just needs to be able to fit those words and then a few numbers in one number in each spot. It's not too big. Okay. One column is input, and one column is output. The input column is your X column. What's another word you think of when you hear X? Domain. It's your domain column. So what do you think the output column would be relating to? The range, which is usually what variable? Y value. But I want you to write this. Do you remember that from yesterday? Do you remember rewriting that up there on the board? Does anyone know how to read this right here?
F of x.
Good. F of x. And if you don't remember that, here's your key. This means f of x. You have to be able to say it that way. And it could be f of x, it could be g of x, it could be pi of x, it could be some random symbol of x. But we're going to give you what those symbols are. But you could see it another way. So that's not the only way to write it, but f of x is good. So what is f of x also known as?
Value.
Quick, all right, fine, yep. Y values. They're talking about your y values. This right here is called a function table. Okay? You know why we call it a table? Because it looks like a table. Why is it a function table? Well, let's put some numbers up here, and then we'll see how the numbers relate to one another. Okay, here on the first column, put 0, 3, and 6. Natalie, according to this function table, what is my domain?
0, 3, and 6.
This is 0, 3, and 6. Good. All right. And then I'm going to put some values to the f of x column, and we'll put here 6, 9, and 12. 6, 9, and 12. Matthew, according to this function table, what is my range? 6, 9, and 12. In that order, right? Okay, but I'm going to start pulling out some other questions, see if you guys can pull out some facts that you remember, hopefully. William, how many ordered pairs are in that function table?
3.
3 ordered pairs is correct. Hudson, give me one ordered pair. 0, 6. This is an ordered pair. Give me another one, Jack. 3, 9. And give me the last one, Drew. 6 and 12. Do you guys see the ordered pairs here? Do you guys see the domain? Do you guys see the range? Okay. Do you see the y? Where is it? It's f of x. Okay, so just be careful. You're going to see that from here on out. All right, what you're going to do when they give you a table is they're going to give you all these numbers. They're going to give them all to you. They want you to come up with what we call a function rule. A function rule. Okay, that's the goal today, to get a function rule or to use a function rule. You're like, okay. Michelle, I'm calling this a function table. But looking at the ordered pairs, is that really a function? Yeah, I don't know. Your guess is better than mine. Anna Grace, this is called a function table. But is this really a function? Is every x value paired with exactly one y value, is what I'm asking.
Yes.
So Michelle, is every x value paired up with one y value? Exactly one y. So it's a function table. So we're going to come up with a function today rule. And it's really not that bad, but it's going to look like this. You're going to write f of x equals something. And what you're trying to figure out here is, how do I go from the input to the output? How do I go from 0 to 6, or 3 to 9, or 6 to 12? What do I have to do to the input to get that output? Anyone know? Add 6 was my first guess here. So this is what I do. This is what I'm mentally checking through. All right, my first input plus 6 would give me what? 6. So that works. That's good. My second input plus 6 would give me 9. That works. My third input 6 plus 6 gets me 12. So is that truly what you do to go from the input to the output? Yes. This is how you write it. F of x equals whatever the input is, what do you think? Plus 6. This is your function rule. That's your function rule. That's what you're going to be doing today. Coming up with that function rule. You're like, oh, that wasn't too bad. Good. I'm glad you feel that way about this first problem. because it doesn't stay this
Simple.
simple. Okay. But it doesn't get too much more difficult because it really could, but we're not going to get to that level yet today. Okay. Now, does this function rule describe the relationship between the input and output? Does it describe it accurately? Hagen, pick one of the domain values. 3. If I put the domain value of 3 into x here, is it going to get me the right range value? Yes. So this describes what that table's all about. All right, let's do another one here. Draw another table. By the way, guys, you're only going to have to draw a couple tables, and then the other problems, they're going to give you the tables. You don't have to redraw them out. They'll give them to you. And that means less work for you, thankfully. Okay, here on this input-output table, which is also known as a function table, what do you think my output's going to be? Not y, but f of x. Good. Just learn how to say f of x. And what does f of x really stand for? Y. So that's all it stands for. But why don't they just put y? Because there's something special about these values. They all relate in a special way. Remember that special word? What am I referring to? Special. Functions. I'm thinking of functions, not just relations. Okay, here are the first 3. 0, 1, and 2. And here are the next 3. Negative 3. Make sure I put these right. Negative 2. Negative 1. Okay. What's my domain, Gracie?
Your domain is 0, 1,
Lana, what's my range?
2. Negative 3, negative 2, negative 1.
Good. Sam, give me 2 ordered pairs. 2 ordered pairs. Give me 1 ordered pair. What should go in this ordered pair? Just one of them.
0, negative 3.
Yep, that's an ordered pair. 0, negative 3. Give me another ordered pair, Jack. 1, negative 2. And give me the last one, Natalie. 2, negative 1. Do you guys see the ordered pairs? Okay, I know I'm drilling some things, and you're like, please stop asking me the same question, but I really want you to get it because you're going to see this in future lessons this chapter, and it's going to be very helpful. I hope. Very helpful. Okay, I'm trying to come up with a function rule, and it's got to be in this format. F of x equals something. How does the input relate to the output? So the first problem, what did I do? I had to add 6. I think that's what we said, add 6. So do I add something to get to negative 3? Let's see, 0 plus... Oh, that's not going to work. What can happen this time? Not 0 plus, but maybe...
You could do 0 plus.
You could. How would you say it?
0 plus 28.
Okay, you could do that, so I'm good with that. But to make it easier, you could say 0 minus 3. Okay, gets you negative 3. That works. So 0 minus 3 equals negative 3. Does that work for this one? Let's see. 1 minus 3 is what? Negative 2. And does that work for the third one? Oh, it works for all of them. So what's my rule? F of x equals...
X minus negative 3.
You'll say x minus 3. That's your function rule. Yep. Could you technically say f of x equals x plus negative 3? Yes. But to make it simpler, x minus 3. Man, that's easy, isn't it? It's not too bad. Good. Let's do another one. Oh my. Oops. Forgive me for this one, but it's good for you to practice it. Okay, each of our function rules, our first 2 function rules, we've had to do one thing. Add something or subtract something. What else might you be able to do, you think? Multiply by something or divide by something. Okay, those are simple function rules where you do one of those. But there are more complicated function rules. That's where you have to do 2 things. Either multiply and divide, that's one thing, and add and subtract, that's the second thing. So let me give you the numbers here. Yeah, we'll go with that. 1, 2, 3, 4, 6, 8. All right, my first thing is to try adding to see if it works out. 1 plus what equals 4? 3. 2 plus 3 equals, that doesn't work. Doesn't work. What about subtracting? 1 minus negative 3. No. It's not going to work. Still doesn't work. If adding doesn't work, subtracting doesn't work, what can we try next? Multiplying. 1 times what equals 4? 4. Okay. 2 times 4 equals, it's not that either. And it's not dividing. It's going to be a 2-step function rule. And I need you to think about it. And you may begin thinking now. Starting now. Some of you are like looking at me. No, I'm not going to tell you. You're going to think about it. The function rule is going to look like this. F of x equals blah, 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 blah. Start guessing. What do you think? You either... Oh, you have one? Okay.
Plus 1 times 2.
Okay. This is what you're saying. I'm writing what you said. Say that one more time.
Plus 1 times 2.
X plus 1 and then times 2? Like that? Something like that?
Yeah.
Okay, let's try it out. What's 1 plus 1? 2 plus, times 2. And really, you technically have to write it like this if we're doing it that way. 1 plus 1 is 2 times 2? 4. Oh, it works. Let's try this one. 2 plus 1?
3.
3 times 2?
6.
Uh-oh, it worked. Let's see if it works for the last one. What's 3 plus 1? 4 times 2? Sam, you struck gold. That has to be the answer. But the way we're going to write it, this is really complicated, by the way. Well, actually, let me do this. The sturdier property, how would I rewrite this? X plus 2 times 1. That's your function rule. Sam, how'd you figure it out? Because I'm curious. Someone else came up with it in the other class. They're like, 2x plus 2. And they're like, but I want to know. You may begin explaining it to me.
Well, I don't know how to explain this, but
Oh, you can try.
I was multiplying by 2 because all those, if you just add all 3 of those numbers to the left to 1 now, you multiply by 2, you get the answer.
Okay, so adding 1
Yeah.
and then adding 2.
No. So, 1 is 1 away from 2, and then if you multiply that by 2, it gives you 4. And then you just add 1 and 2, and then you multiply by 2, and then add 1 and 3. So you all have to add 1 to the left side, and you all have to multiply 2.
That's logical. So good job on that. Okay, how many of you maybe struggle with that? You're like, I still don't see how someone could have gotten that. Okay, thank you for being honest. A lot of your classmates should be doing this as well, but it's okay. You're going to have one of these problems where you have to get a 2-step rule. Most of them are going to be the 1-step like we looked at with the last examples. Okay, but it's time for you to start working on your own here. This time what I want you to do is not to come up with the function rule, because what did I already give you? The function rule. You're like, wait, where's f of x? Where's f of x? It's y. It's right there. Okay, what you have to come up with is a function table, and all you have to do is pick 3 values for x, and then come up with the output values for y. So what I want you to put here, you're going to put x, and then y, which is really f of x, same thing, you can use them interchangeably, and here's what you get to do. You get to pick any 3 domain values you want. This is going to be coming up with a function table when they give you the function rule. So I want you to pick 1 positive number, 1 negative number, and always use the number 0 because it's so special. So who can give me a positive number? Just pick anything. 1. Oh, make it really tough on us. All right, 1. And then we're going to pick 0. We're all going to do 0. And then someone else pick me a negative number. Good choice. Sorry? Thank you. -8. I'm good with that. Okay, if your domain value was 1, what would be the range value using that function rule? 2. You just add 1 to the domain value. If you had 0 as your x value, what happens with your y? You get 1. Good. And when you put -8 as your x value, what do you get for your y value? -7. -7. Be careful. Yeah, it's -8 plus 1, -7. Okay, cool. Is this a function? Okay, sorry. Is this a function in this function table? William, what do you think? Is it a function?
Yes.
Okay, he says yes. Why, Jackson? Is it a function table?
Because
Every x value has exactly one y value. Perfect. Jack, is that a function?
Yes.
Good. Hudson, why is that a function?
Because every x value has exactly one y value.
Perfect. So does 1 only have one y value? Yes. Does 0 only have one y value? Does -8 only have one y value? Good. It's a function. That's what we call a function table. That's pretty interesting. That's all you had to do. Now, did everyone have to pick 1? Did we have to pick 1? No. You could have picked 10. You could have picked 7. Any positive value. Could you have picked, yes. Could you have picked any negative value? Yes. What number must you pick, though? 0. And that's because it's so special. Give me a function table with this function rule. You pick a positive, a negative, and 0, and then get me whatever the y values are going to be. So your function tables may not look the same, and that's okay. And I prefer if you put 0 in the middle value because you're going to put either the positive, negative first and then the opposite last. There's a reason why I do that. Try to put that 0 in the middle and then pick any positive, negative. Any number you want. Just don't go too wild. And then you have to come up with the y values that match up with those x values. Okay, Matthew, what's your positive number?
1.
1. Oh, nice. Sophie, what's your negative number?
-10.
-10. Very good. And then all of you should have put 0. Okay, if you picked 1, anyone else pick 1 for their positive? Okay. Those high rollers there. 1. What's 2 times 1? 2 plus 5? 2 times 1 is 2 plus 5 is 7. Okay, so you should have got 1, 7. How many of you got an ordered pair 1, 7? Okay, everyone who had 1 as their domain value should have gotten that as their ordered pair. All right, all of us picked 0, right? What's 2 times 0? 0 plus 5. So you should have got, everyone should have had the order pair 0, 5. Every single one of us. 0, 5. And then, Hagen, what'd you get for your y value if you pick -10? So I'll give you some time. If you pick -10. Close. -5. Yeah, that's tough. Why is it tough? Because you have a negative. So what's 2 times -10? -20 plus 5? -15. All right. Who picked a different who picked a different negative value? That's closer to 0, so maybe not -20. Please don't give me that. Yep.
-1.
Oh, nice. Very good. Very good. -1. What was your y value with that -1?
+3.
Okay, 3. How many of you picked -1 and got 3? Anyone else do that? Okay. All right. Here's what I want you to do, or just look at it here. We're not doing a graph on our own, but there's something special about all these ordered pairs you came up with. Okay. 1, 7. I'm going to estimate where it should go up there. So somebody tell me where does 1, 7 go? I'll just draw it. Yep. Oh, swivel. It just did it? Okay, cool. Thank you.
How does that?
It's because when I turn around, it loses track of me, and it keeps going where it thought I was going. So Swilm and I are having communication issues. Okay, 1, 7. Who could tell me where 1, 7 goes? Yes, go ahead.
So 1 to the right, up 7.
1, 2, 3, 4, 5, 6, 7. So somewhere up there. Okay, someone give me how to get to 0, 5. 0, 5. Go ahead.
And there, and then go up 5.
1, 2, 3, 4, 5. All right. And somebody tell me where to go. -10, -15. Jack?
You go down to the left 10.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
And then down 15.
Somewhere down there, right? 1, 2. Can you remember that?
Yes.
Just right about there. Keep your reference there. And then where's -1, 3? I love the enthusiasm. You know what those 3 plus that 1 point would form? A line. Ready? Remember that point? Let's see if I can do this here. Ready? Remember that point? Let's see. Because of error. Oh, look at it. It made it. It formed a line. Did anyone pick another point that I haven't listed out here? Anyone else have another ordered pair? Give me an ordered pair, please. Somebody. Yep.
-4 and -3.
So -4, -3. All right. 1, 2, 3, 4. 1, 2, 3. So like somewhere right here. Man, my graph is looking bad. Worse and worse every time. Anyone pick a different positive number?
So, I have, well, do you already have us 5 and 15?
Nope. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right there. And it would fit that line. Really would. Yep.
3 and 11.
1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh, I mean, that's pretty good. What should all our points, if we put them all in the same coordinate plane, what should they all form?
A line.
A line, which tells me this. How many possibilities did I have here? You're getting there. How many? Infinite numbers. So on these answers, when you get this graph, some of them are going to look the same, some are going to be completely different, but they should all, if I graph them, be put on a line. That's what we're talking about, a graph of a function. And just before you forget, remember this? You remember what this is? Oh yeah, it's a vertical line.
Vertical line?
What do you know about this? It always passes, doesn't it? It's a function. That's a function rule. Okay, your homework. 2 to 22 even. Goodbye, Swivel.